Okay, in this session, let's look at the various methods which we are using to compute the value at risk, especially from a market risk standpoint. The various methods that are used for assessing the risk that is associated in a security or a portfolio. See, there are so many approaches to measure the risk. We have already seen in case of bonds. We have looked at duration, we have looked at key rate duration, we have looked at the regression based hedging, the various mechanisms to actually identify the risk amount as well as come out with the mitigation hedging kind of mechanism. This is one of the newly evolved mechanism in terms of finding out how much of your amount is really at risk. It is applicable for all: market risk, credit risk, operations risk. For every risk, there is a mechanism of computing the VAR. So there are few traditional approaches. See, the way the VAR is actually represented is with this kind of a notation. Probably 1% daily VAR is equal to probably $5,000. What does this mean? There is a 1% chance, which is something to do with the confidence level and significance levels. Every time the VAR has to be quoted in this way itself. There is a 1% chance that on a daily basis, my portfolio will lose, portfolio or security or whatever it is, my portfolio will lose more than 5,000. So that's the typical definition of a VAR. Today, almost the banks have to report the VAR on their daily basis. This is simply the way we are defining, and Basel also has defined some of the requirements for market VAR, credit VAR, all kinds of VARs associated. And at the end, it is nothing but it's a way to quantify statistically the minimum possible loss for you. Minimum in sense 1%. I mean, the chance of a loss of 5,000 or more is only 1%. So I may end up doing a 5% VAR or a 1% VAR, or in some cases even a 0.1% VAR kind of scenarios are also there as a part of the requirement. So what is the chance of losing more than this much? On a daily basis, on a monthly basis, whatever may be the frequency that is associated with it. That is what we are defining the VAR. And there are 2-3 traditional methods that are there in the computation of this VAR. Some of them are parametric methods. When I say parametric, you are actually going with computation of mean, standard deviation, some of the parameters of the data, and based on that you are deriving the VAR. Whereas there are some non-parametric kind of methods also that are existing in the market. So they are the very traditional means of finding out the VAR. But as the advanced approaches are coming up, obviously the way you model, though the base is still those traditional approaches itself, but the inputs that are going into them are becoming more and more complicated. So in that, when I am looking at a parametric kind of an approach, it makes an assumption that your returns will follow a normal distribution, or some distribution for that matter. But in general, we see that the returns are following a normal kind of a distribution. Under the assumption of returns following a normal distribution, the parametric mechanism of approaching your VAR, right? The parametric mechanism of approaching your VAR will decide what is that particular amount, which is the cutoff point where the loss beyond that, the chance is only 1%. Right? So here the cutoff point is 5,000 bucks, where the loss beyond that, beyond 5,000, the chance is only 1%. So that is what we are calling as a VAR, and we are trying to define the VAR in any of the investment process. So now let's say if, on this Infosys security itself, I have to find out the VAR. For last 1 year, I have taken the daily prices of this particular security. Okay, I think I have to take it in the ascending order. I'll take it no issues. So let's say these are the last. Okay, let's say these are the last 1 month prices, 1 year prices, and I'm taking the returns. And so probably I'll take a continuously compounded kind of a returns. Continuously compounded returns are coming out through the logarithm process. So I am taking a continuously compounded kind of returns over the last 1 year period. Now I am assuming here to use the VAR. I am assuming that the returns are following a normal distribution. I can probably check out also if they are following a normal or not. Probably using a skewness kind of stuff, I can find out whether the returns are following a normal distribution or not. They are not. So there could be a couple of outliers in our data or something, which are actually not making our returns follow a normal distribution. So probably if I try identifying those 2 or 3, okay, let's see if after removing these 2 or 3 outliers, yeah, very much. So let's assume that this is following a kind of a normal distribution, right? If the returns are following a normal distribution, what this mechanism is saying is, you find out the mean. See, normal distribution, how does it look like? This is the kind of a normal distribution, right? We know that this is the mean, right? Standard deviations wise, if I am taking this particular point wherein this part is 1% and this part is 99%, I can very well identify what is this particular value. So which is nothing but those many standard deviations away from the mean, right? And we all know if it is following a normal distribution, this is, if I want the 1% here, it is nothing but 98% confidence interval. Whatever is the value that is corresponding to 98% confidence interval, the because the 1% this side, 1% this side, if I am taking out, the interval is corresponding to 98. So basically the value is minus 2.33 standard deviations from the mean. So what I can very well do is I